Features of earthquakes. When two people hold opposite ends of a rope or a slinky and shake one end, they send energy through the rope in the form of waves. Like the waves that travel through the rope, seismic waves generated by an earthquake travel through Earth. During a strong earthquake, the ground moves forward and backward, heaves up and down, and shifts from side to side. The surface of the ground can ripple like waves do in water. Imagine trying to stand on the ground that had waves traveling through it. This is what you might experience during a strong earthquake. Rocks move past each other along faults, creating stress at points where the rock's irregular surfaces catch each other. The stress continues to build up until energy is released in the form of seismic waves. The point where this energy release first occurs is the focus of the earthquake. Seismic waves are produced and travel outward from the earthquake focus. So down here, you can see this line is called a fault. And this is where the rocks are moving past each other and creating energy, right? This little yellow dot where the earthquake waves are radiating from is called the focus. When earthquakes occur, three different types of seismic waves are produced. All of the waves are generated at the same time, but each behaves differently within Earth. Primary waves, or what we call P waves, cause particles and rocks to move back and forth in the same direction that the wave is traveling. It is the most basic earthquake wave. If you squeeze one end of a spring or something like a slinky and then release it, you can cause it to compress, which means to squeeze together, and then stretch as the wave travels through the spring. Particles and rocks also compress and then stretch apart, causing primary waves to travel through the rock. See the picture below. So if you look at that, here's a primary wave. It's traveling to the right, but look at what's happening. Kind of like if you were to gather up a part of a slinky, see how it's compressing in certain areas? There's certain areas where it's a little tighter than others. Secondary waves, or what we call S waves, are the second type of wave that an earthquake makes. They move through Earth by causing particles and rocks to move at right angles. So they just go to the opposite direction of the wave travel. See the example below. So this one looks like a classic wave, right? Like if you took a rope and just went up and down, you can see the lines going back and forth. So that's the second kind of wave that an earthquake makes. Surface waves are the third type of wave from an earthquake, and they cause the most destruction. Surface waves move rock particles in a backward, rolling motion and a side to side swaying motion. Many buildings are unable to withstand intense shaking because they are made with stiff materials. The buildings fall apart when surface waves cause different parts of the building to move in different directions. So down at the bottom of this chart, you can see the P waves, right? Look at where they compress. Then you can see like the classic S wave, right? Up and down. And then surface waves, you see, are kind of moving back and forward. They're rolling kind of in a circle. This is where the most damage is going to occur on the surface. Surface waves are produced when earthquake energy reaches the surface of the earth. Surface waves travel outward from the epicenter. The earthquake epicenter is the point on Earth's surface directly above the earthquake focus. See the epicenter and earthquake focus in the picture below. So if you look at it here, the line again is the fault. The rocks are moving past each other, right? So the focus is underground, right, where the P and the S waves are generated. But once the waves get to the epicenter and they radiate or move away from the epicenter, those are the surface waves on top, on the actual surface, the where we are. Different seismic waves travel through Earth at different speeds. Primary waves are the fastest, secondary waves are a bit slower, and surface waves are the slowest. Like runners in a race, seismic waves travel at different speeds, and scientists have learned how to use the different speeds of seismic waves to determine the distance to an earthquake epicenter. When an epicenter is far from a location, the primary wave has more time to put distance between it and the secondary and surface waves, just like the fastest runner in a race. So that's how people determine where the epicenter, where the earthquake actually starts, is they look at how fast the waves are moving and where they're going. Seismic waves from earthquakes are measured with an instrument called a seismograph. Kind of makes sense, right? It's a graph, or it's going to generate a graph, and size is the same beginning as seismic, right? Seismographs register the waves and record the time that each arrived. Seismographs consist of a rotating drum of paper and a pendulum with an attached pen. When seismic waves reach the seismograph, the drum vibrates, but the pendulum remains at rest. The stationary pen traces a record of the vibrations on the moving drum of paper. The paper record of the seismic event is called a seismogram. The pictures below show what seismographs looks like. So kind of the original seismographs look like this, right? You've got a rotating drum, and when the earth moves, this pendulum goes back and forth and writes on the paper, right? So if the earth moves more and is shaking more, you're going to have a more violent back and forth than just a little earthquake, right? And then kind of here's a more modern seismograph, right? They're built into the wall. Here's the roll, the drum of paper. And then look at as this is moving, so obviously this one on the left here is a lot less powerful than this one on the right, right? Or it's recording different waves. So that's it. Now you're going to go back and you're going to look at the bloopers and you're going to read each sentence and say, okay, what doesn't go? So number one, waves that travel through Earth and are generated by an earthquake are called sesame waves. That doesn't work. So you're going to highlight this, and underneath you're going to write what it should be, right? Which the answer should be seismic. Okay, good luck. That's your homework.